Good day everyone, we are group 7 and we'll be doing the experiment number 10 entitled Determination of Optimum Moisture Content by Standard Proctor test. So the compaction of soil is a mechanical process of ground movement that involves densifying the soil by reducing the volume of air in the soil mass through an external compactive effort. This moisture content is termed as the optimum moisture content, and the corresponding unit weight of soil is called the maximum dry density. With this, we are using the reference standard of the ASTM D698. The objective of this experiment is to investigate the moisture density relationship of soil. The materials and equipment are the following: compaction rammer, number 4 sieve, metal pan, rubber mallet, straight edge tool, trowel, mold assembly, graduated cylinder for the water, soil sample, water, and of course weighing balance. First is we clean the mold and measure its dimensions, the height and the diameter, and weigh the empty mold on the weighing balance without the collar. Second, we weigh the empty mold on the weighing balance again but with the collar.
So now we are sieving the soil with number 4 sieve. So we're gonna put the number 4 sieve soil in the molding assembly.
I'll take one.
So we are going to weigh the sample.
Next, we would attach the collar and fill the mold again with soil until it is full.
We're going to weigh the sample with the second layer.
11.64 grams.
So now we are going to fill the graduated cylinder up to 296.5 for the 8% of the soil.
So now we are going to pour the 8% of water to the soil.
Mix the soil with water thoroughly in preparation for the first compaction trial.
So now we're gonna put the soil with 8% of water in the molding assembly. We're gonna perform 25 blows on the sample. Now we are going to weigh the soil with the 8% of water. This is the first trial. So 9.48 kilograms. So we're going to add 5% to the sample.
After adding the first 5% of water, we then just repeat the procedure of putting the soil into the mold assembly, compacting it, and also weighing it. We keep adding water until the moisture content exceeds the optimum water content, and it would be reducing the soil unit weight. At this point, this is already the 5th trial, and this is the trial that the unit weight of the soil has already reduced or decreased. So from 10,185 grams, it dropped to 9,830 grams. To reiterate, we use the reference standard ASTM D698 for this experiment, or also known as the standard test method for laboratory compaction characteristics of soil using standard effort. In this part of the video presentation, we will now proceed to the results and discussion of the experiment. So for the results and discussions, we have prepared data sheets that would explain our data that we have gathered during the laboratory experiment. So first we have the table 1, which is entitled Standard Proctor Test Procedural and Equipment Specifications. So we have the mold diameter in centimeters and also the mold height, which is 15.2 and 17.6 respectively. We also got the volume of the mold, which is in cubic centimeter. This can be solved through the volume of the cylinder, which is pi r squared h, and we got 3,193.67 cubic centimeter. Mass of the mold without the top or without the color is 6,195 grams. Mass of the mold with the top or with the color, we have 7,940 grams. And lastly would be the mass of the dry soil, which equated to 3,705 grams. Next is table 2, or entitled Bulk and Dry Density Determination. So as you can see in the row 1, we have the compacted soil specimen trial, which we have done 6 trials all in all. The second row is all about the water content that we have added in our soil per trial. For the first trial, we had 8%, and then we added 5%, which made it 13%. For trial 3, we have 18%, 23%, 28%, and 33% for the last trial. Next would be the mass of added water. Since we got 8% of the water content, this would equate to having 296.5 grams of added water that we will be adding in the soil. Next, we have 13%, which yielded 482 grams of water, 667.5 grams for trial 3, so on and so forth. Next, we have the mass of moisture can without the top plus the moist soil. So those are the data. And we have the mass of the moist soil. We just subtract this, which yielded us these results. And lastly, the bulk density and the dry density. The solutions will be shown in the next slide. So here we have the solutions for the bulk and dry density that would be very crucial for attaining our objective for this experiment. So first, we have the bulk density. The formula would be the mass of the moist soil over the volume of the mold or the cylinder assembly mold. So we have here the results. For the bulk density for trial 1, we have 3,285 over the volume, 3,193.6, which equated to 1.0286 grams per cubic centimeter, so on and so forth. Next, we have the dry density. We follow the formula of the bulk density over 1 plus W, or the water content. If we try to observe the data for the dry density, the highest dry density that we have is for trial 3, which is equal to 1.0230 grams per cubic centimeter. And that would be very beneficial in plotting for the graph. And the moisture content for this trial is equal to 18%. And now we will be moving to the graph of this experiment. So in the graph, we have the x-axis and also the y-axis. The x-axis is all about the water content in percentage and the dry density for the y-axis. So here we plotted the 6 dry density with its corresponding moisture content. And from here, we would be able to analyze and get the result that our optimum water content is 18%. Since this is the highest value or the peak value before it decreases. So we have also the maximum dry density, which is equal to 1.0230 grams per cubic centimeter, which is also aligned with the 18% of water content. In addition, we have also achieved these results since we have done this in accordance with our reference standard ASTM D698. To conclude, the 18% water addition is the optimum moisture content in that particular soil sample, which means adding below or higher than the level will result in a decrease in dry density of the soil, and that can be shown in the graph. And that concludes our video presentation. Thank you very much.